everyone, for today's lesson we are going to learn how to write quadratic functions and models. Our learning objectives for today is for you to be able to say I can write a quadratic function in vertex form given the vertex and a point on the graph. I can write a quadratic function in intercept form given the x-intercepts and a point on the graph. And our last one is I can write a quadratic function in standard form given at least 3 points using the graphing calculator, which means this lesson is a graphing calculator lesson and you will need to have a graphing calculator in order to complete this. Please make sure that you have all of the tools that you need in order to be successful in this lesson. Okay, so this is our very last lesson of the unit, and we have learned a lot about quadratics and we've studied them very intently. And so today's lesson is kind of bringing everything back together and full circle. We're going to start today off with vertex form. And we're going to learn how to write a quadratic function in vertex form. And remember that vertex form is y equals a times x minus h squared plus k. So what's going to happen is you guys are going to receive a graph or receive some information in which they tell you what the vertex is and they give you a point on the graph. What you're going to do is you're going to substitute the values of the vertex in for h and k into our equation. Then you're going to substitute the values of the other point for x and y. So we've talked about all of the values except for one, and that's a. And you'll solve for the missing value of a. Then you'll write your final answer in vertex form, remembering to put put x and y back into the function, and they will remain your variables. So what you're going to do when you put it into vertex form is you're going to actually use the vertex that is given to you for h and k into the original problem. Okay, looking at example number 1, it says write a quadratic equation for the parabola shown in vertex form. So if you look at this problem, we already know what h and k is. That's our vertex and it's located at -2, -3. So that means h is equal to -2 and k is equal to -3. And using that information, we can already write our equation as y is equal to a times x plus 2 squared minus 3. So the piece that's missing is our a value. Fortunately, we are given a point, 0, 5. So that means we're going to let x equal 0, and we're going to let y equal 5, and we're going to find what a is. So I'm going to let y equal 5 by writing 5 equals, I don't know what a is, so I'm just going to write the letter a, times x is 0, plus 2 squared minus 3. My job at this point is to solve for a. So 0 plus 2 is 4. 0 plus 2 is 2. 2 squared is 4. So this is 5 equals a times 4 minus 3. And I'm going to clean up this equation so that it's a lot easier to read and solve. So this is 5 equals 4a minus 3. And now we're just solving a normal linear equation by adding 3 on both sides. We will end up with 8 is equal to 4a. And then I'm going to divide both sides by 4 and find that a is equal to 2. So now that I know what a is equal to, my equation is going to be y equals 2 times x plus 2 squared minus 3. And that is it. That is all she wrote. The next type of function that we learned about was intercept form. And intercept form is y equals a times x minus p times x minus q. So this time you're going to receive a graph, or you'll receive some information in which you will know the x-intercepts and a point that's on the graph. And once again, the piece of information that you will not know is your a value. So you're going to substitute the values of the intercepts in for your p and your q. Then you'll substitute the values of the other point that's given to you for x and y. The value that is missing is a. Then you will want to write your final answer in intercept form. that means that you're going to use the x-intercepts given to you for P and Q. And you're going to need to remember to put x and y back into the function because you will actually be writing an equation. So looking at this problem, we can see our two x-intercepts. They're located at -3, 0 and 2, 0, which means that my p-value is -3 and my q-value is 2. If you flip them around and said p is 2 and q is -3, it doesn't really matter. But where we're at right now is we have y is equal to a times x plus 3 times x minus 2. Remember that whenever you substitute into parentheses, it's always the opposite of what you see. So the thing that we're missing is our a value. Fortunately, I was given a point. And at this point, I have x is equal to -2 and y is equal to -4. And I'm going to substitute these values into my equation, and I'm going to find what a is. So my y value is -4. My a value is what I want to find. X is -2, so I'm going to write -2 plus 3. And x, once again, is -2, so I'm going to write -2 minus 2. Simplifying each parenthesis, this is -4 is equal to a times -2 plus 3 is 1, times -2 minus 2 is -4. I'm going to multiply these numbers and put this as a coefficient in front of a. So now I have -4 is equal to 1 times -4 is -4. So I'm going to write -4a. Dividing both sides by -4, we end up with 1 is equal to a. So our equation is y equals 1 times x plus 3 times x minus 2. Or we don't have to write 1 right here. Instead, we can simply write y is equal to x plus 3 times x minus 2. And that is your answer. So far that's vertex form and intercept form. And what I would like you to do is please go ahead and pause the video and please try example number 3 and 4 on your own. These are your turns. The only difference is at this time I'm not giving you a graph, and instead I'm giving you relative information for you to write a quadratic function in a certain form. Hopefully it's obvious which form that you will use. All right, let's see how well you did. First of all, they gave you x-intercepts, which means that we're going to be working with intercept form. Our p-value is -2, our q-value is 1, and so starting off this problem, we have y is equal to a times x plus 2 times x minus 1. Now, you do not have to start off this problem by writing it like this, but I think it's helpful, especially for my visual learners, for everyone to see what's going on. The point on the graph is -1, -4, so I'm going to let x equal -1, y equal -4, and we want to find what a is. So I'm going to write -4 is equal to a times -1 plus 2 times -1 minus 1. So this is -4 is equal to a, -1 plus 2 is 1, -1 minus 1 is -2. 1 times -2 is -2, so I have -4 is equal to -2a. I'm going to divide both sides by -2, and we find that a is equal to +2. So my equation is y is equal to 2 times x plus 2 times x minus 1. For example, number 4, they gave us the vertex, so hopefully it's obvious that we're working with vertex form. In this case, my h value is 2, my k value is 1, and so far I know that y is equal to a times x minus 2 squared plus 1. What's missing is our a value, but fortunately we have x is equal to 0 and y is equal to 4, and we simply need to find what a is. So y, which is 4, is equal to a times x, which is 0 minus 2 squared, plus 1. 0 minus 2 is -2. -2 squared is 4. So I'm going to write 4 is equal to 4 times a plus 1. So I simply brought this number out in front and skipped a step. I am going to subtract 1 on both sides, and we end up with 3 is equal to 4a. And now I'm going to divide both sides by 4, and we find that a is equal to 3/4. So my equation is y equals 3/4 times x minus 2 squared plus 1. Hopefully you did pretty well on these your turns, and you got them both correct. And if you didn't, hopefully you were able to identify your error. So now you need a graphing calculator. So if you need to pause the video to take out your graphing calculator, please make sure that you do so. You will be responsible for knowing how to use your graphing calculator on your next test. So it says write a quadratic function in standard form. Standard form is y equals ax squared plus bx plus c using our graphing calculator. So what's going to happen in examples 5 and 6 is I'm going to give you a set of ordered pairs, and your job is to enter the x and y values into your calculator. Before we do anything, the first thing I want you to do is I would like you to please clear your calculator by pressing the second button and then the plus sign button. So pressing second plus sign. A lot of your calculators will have the entry called clear all lists. So under clear all lists, I'm going to press the arrow, or I can press the number 4. It's going to say, whoops, clear all lists. There we go. It'll say clear all lists. Is that what you want to do? You're going to say yes, and I'm going to say enter. And you might have to press enter twice until you see the word done. That's what you want to see. If you do not see the word done, then you didn't clear your lists. Another approach is to go second plus sign, 712. This will completely clear the RAM on your calculator. And reset everything back to the original state that the calculator came in. Okay, it's important for you to do that every single time so that you don't have junk or any sort of other data inside of your calculator. Now, in order to enter data into your calculator, we're going to go to the Stat button. And under Stat, we're going to go to Edit. And this is part of step number 1. So I'm going to press Stat. Stat is located below Delete. And we're going to go to Edit. So I'm going to press either the number 1 or simply the Enter button. We are going to put all of our X values into list 1 and their corresponding Y values into list 2. So L1 is your X and your L2 is your Y. So looking at example number 5, I have the ordered pairs given here. And L1 once again represents X, but all of my X values are -2, 0, and 2. And my L2 is all of my Y values that match. So it needs to be in that specific order of -6, 6, and 2. So that's what I'm going to enter into my calculator. -2, and I'm going to press either the down arrow or enter, 0, and 2. Then I'm going to press the right arrow to change over to a different column, and I'm going to enter in -6, 6, and 2. Once you have your data entered into your calculator, the next thing we want to do is we want to calculate a regression. This regression will tell you the actual equation that represents or that goes through the ordered pairs that we have. So once again, you're going to press that Stat button again, but this time we're going to press the right arrow to go over to calculate. So I'm going to press Stat again, even from this table. And we're going to press the right arrow to calculate. And we want to calculate a quadratic regression. So we want to go down to where it says Quadrag. And we're going to press enter. Some of your calculators will show just Quadrag as a word, and all you'll need to do is press enter. Some of your calculators will have L1, L2, frequent list, etc., like my calculator shows, and that means you'll have to press enter 5 times. So it just depends on what type of calculator you have. But if you press it 1 time or 5 times, you should all end up with the same screen as me. And in this problem, they tell us that the A value is equal to -2, Our B value is 2 and our C value is 6. And we're going to plug all of these values into the standard form. So that's going to be y equals negative 2x squared plus 2x plus 6. And there's your equation. There's not a lot of work to show or anything to do. Please try number 6 on your own. See if you can do these problems without my instruction. Fast forward the video and see if you end up getting the right answer. If you still need to see the steps again, feel free to just watch me go ahead and do example number 6. All right, here we go. So we have new data. I forgot to mention something. If you end up with non-perfect numbers and you end up with like decimals or something crazy like that, round your answers to the nearest hundredth place. Or tenths place, depending on what the directions are asking you to do. All right, so we have new data. So that means that we need to clear our list. So I'm going to press second plus sign, go down to clear all lists. I'm going to press enter and wait until it says done by pressing enter again. Next, I'm going to go to stat and then edit, and my list 1 and list 2 should be cleared. And in list 1, I'm going to put in -7, -3, and 5. Those are all of my X values. In list number 2, I'm going to put all my Y values, which are -92, -12, and -44. Always look at your ordered pairs, make sure they match, make sure that there's no issues, otherwise you'll end up with an incorrect regression. Next, I'm going to press stat. I'm going to press the right arrow over to calculate. We're in the quadratic units, so we're going to go to quadratic regression, number 5. I'm going to press enter. I have to press enter 5 times to calculate, and I end up with my A value equal to -2, my B value is equal to 0, my C value is equal to 6. So I'm going to write this as y equals -2x squared plus 0x plus 6. Now 0x can be eliminated because anything times 0 is 0 and anything plus 0 is just itself. So I'm going to write y is equal to -2x squared plus 6, and that is my simplified version of that equation. All right, we have one more example and then we are done with this lesson. So in example number 7, it says the table shows the horizontal distance in feet traveled by a baseball hit at various angles. The initial speed of the baseball at the bat is constant. The angle in degrees is given, and how far it travels is also given. The angle or the distance is dependent on the angle. Therefore, the angle will be x and the distance will be y. And once again, this is going to be your list 1 and your list 2. So you're going to want to go to your graphing calculator. You're going to want to clear all your lists by pressing second plus sign. I'm going to clear all my crazy. Here we go. I have done. Awesome. And then you're going to want to go to stat, edit, and then enter your values into list 1 and list 2. I'll try to go as quickly as I can. Not supremely exciting watching me enter in data, but hopefully your data entry is the same as mine: 10, 15, 24, 34, 45, 48, 58, 64. 115. Verify my numbers: 115, 157, 220, 269, 285, 277, 244, 180. Awesome. So all of my data has been entered in, and it says for letter A, create a scatter plot of the values in your calculator. Why would we use a quadratic regression for this data? So in order to create a scatter plot, what you're going to do is you're going to press second and y equals. And after you press second y equals, you want to go to where it says plot 1 and you'll press enter. You'll want to make sure that your plot 1 is on by, if you see it's blinking, you press enter and now it is on. The type is scatter plot. We want to use list 1 and list 2. It doesn't matter the mark, that's whatever floats your boat. And mine has color. Yours probably, maybe it does, maybe it doesn't matter. I'm using blue. All right, so now that my plot is on, I next want to be able to look at my scatter plot. So I am going to press zoom stat. So go to zoom and then go to stat. So if you press the zoom button, you'll need to go all the way down to where it says stat, or you can press the number 9. That will also get you to zoom stat. And now we have ourselves a picture of a scatter plot. And when you look at this, notice that it has like a parabolic shape. It looks like it's kind of a U. And so because it has that parabolic shape, we would use quadratic regression. So why would we use quadratic regression? Because the scatter plot forms a parabolic shape. If it was a line, a linear regression would be appropriate. If it was a different type of function that we've discussed in Algebra 1 or even in this class, we would use a different kind of regression. So it makes sense for us to use a quadratic regression. So now it asks, what will our sine of A be? Well, if you look at this parabola, it appears to have a maximum value somewhere up here. So we would anticipate that our A value should be negative. And that is because the parabola or the parabolic shape is pointing down. And there appears to be a maximum. Now it says find that quadratic model to represent this data. So going back to our graphing calculator, we want to go to stat again. Then we're going to press the right arrow over to calculate. And we want to go down to quadratic regression. I'm going to press enter. I have to press enter 5 times. And ooh, I ended up with different kind of numbers, but that is okay. We want to round these to the nearest hundredth. So my A value is going to be located at negative 0.18. My B value is going to be located at 14.65. And my C value is going to be located at negative 20.15. So my model is going to be y is equal to negative 0.18 x squared plus 14.65x minus 20.15. So here is my model. And what we want to do for letter D is it says the left field fence is 270 feet from home plate. At what angle or angles to the nearest 1/10 of a degree will the ball be hit past the left field fence? So this is our distance in feet. So this is what we want to let y equal. So we want to let y equal 270 feet, and we want to figure out what angle, and the angles in this case were all of our x's. So we want to solve for x. So the best approach for this, in order for us to not have to use the quadratic formula and use our calculator to our advantage, is I want you to put in y1 the function that we wrote up here for letter C, and in y sub 2, I want you to let that equal 270. So we're going to press y equals, and in y equals, we're going to enter in our equation. And I'm going to write negative 0.18 x squared plus 14.65x minus 20.15. In y2, I'm going to enter in 270. And now I'm going to press graph. Don't press zoom stat again. You don't have to because it already should show that the model that we had was pretty close. This is a regression, so that means that it's not necessarily going to be perfect, but it's going to be really, really close. And then we have this line going straight across. So what we want to do is we want to identify the intersection. The intersection is going to provide us with our answers. So our intersection comes from pressing second and then our trace button. So pressing second and then trace, and then going to intersect. And we will have to do this twice because it appears as if this line crosses the parabola at two locations. So I'm going to press second, trace. We want to go down to where it says intersect, and I'm going to press enter. It's going to ask you, is this your first curve? So you want to try to get as close as you can to 270, and it looks like the closest I can get to it is 270.000092. So I'm going to press enter and say that's my first curve. The second curve will automatically change the y value to 270. So I'm going to press enter again. They're going to say, is that your guess? And I'm going to say absolutely by pressing enter again. And voila, there's your intersection located at 34.1. So that is 34.1 degrees. Putting it into context because we're talking about angles. 34.1 degree. Next, there's another point of intersection. So I'm going to press second trace again, go down to intersect again. Only this time I'm going to move my blinking bug or cursor all the way over to where it's once again as close to 270 as I can possibly make it. And it looks like 270.06 is pretty close. And I'm going to press enter. It's going to change it to 270 as y equals to the second curve. And you're going to say, cool, that works for me. Enter, and then enter again. And therefore, the point of intersection is located at 47.3. So that is 47.3 degrees. So our two angles that would be created, or that would create or cause a ball to go 270 feet past home plate, is 34.1 degrees and 47.3 degrees. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.